Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month for March 2023. I'm your host, Dave McDonald, and you can email me any questions you might have to astromannh@gmail.com. Hey, want to go to Mars? We have a great show. We're going to talk about getting humans to Mars, how and when, with Chris Carberry, the Executive Director of Explore Mars, coming up in just a moment. I want to let you know about a special program happening at the McAuliffe Shepard Discovery Center. So on Saturday, April 8th, from 1 to 4 p.m. Now, we're open from 10:30 to 4. The whole museum is open, but we're having a special program from 1 to 4, April 8th, which is the pre-anniversary of the total solar eclipse coming to New Hampshire, April 8th, 2024, and that will be Monday. But we're going to have the Eclipse Mobile will be there. We'll have solar telescopes observing in our observatory, special programs talking about what the eclipse is going to all be about, some swag to give out, eclipse glasses. It's going to be a great day. And then somewhere around 3:35, we're going to be able to see exactly what the sun is going to look like in terms of its altitude above the horizon. It's not going to be in an eclipse, but we're going to be able to check out where the sun will be at the moment of eclipse a year from April 8th. So come on down to the McAuliffe Shepard Discovery Center in Concord, New Hampshire. It's going to be a great time for the whole family. And you can check matters out at starhop, starhop.com. Now, speaking about Mars, we have a lot to say about Mars and the other planets after our interview coming right up. But I want to show you the image that's behind me. I want to bring that to the foreground and just mention that what you're looking at there is the Perseverance rover and the Mars helicopter Ingenuity. And I want you to know that we just finished or just passed the 2-year anniversary of the landing of Perseverance with Ingenuity on Mars. That was February 18th, 2021. And Ingenuity, which is the helicopter, was intended to hopefully have 5 flights. Well, as of this recording, we're looking towards flight number 45. Can you even believe that? 45 flights, and apparently still going strong for many more flights to come. And it's just neat to note once again that under the solar panel of the Mars Ingenuity helicopter is a piece of the Wright brothers airplane. Some fabric from the wing of the Wright brothers airplane is on Mars. How fitting. Well, let me introduce to you our guest. He's zooming in from Washington, D.C. Chris Carberry is the Executive Director for Explore Mars, and you can check out his website at exploremars.com, and was the CEO of the Mars Society as well. And he is in Washington, D.C., promoting getting humans to Mars safely and as soon as possible. Welcome to our show, Chris.
Thanks for having me on.
Chris, tell us, why do we want to go to Mars? Is it worth the trouble?
Now, this could take up like 10 hours just for me to answer this, but I'll do it. As promised, I'll try to do this as quickly and efficiently as possible. Okay, probably with 4 or 5 reasons. Probably the top one is to determine whether there is life on Mars. Wouldn't be intelligent life, but there is strong evidence there could be microbial life on Mars. And if we are able to discover that, think of the implications of life in the universe if 2 planets that are side by side have life on them. And so it probably will take humans going there before we really figure out if there truly is indigenous life on Mars. But even if there isn't, another big reason is we want to find out if life can survive on Mars, human life. We want to see if humans truly can expand out into the solar system and into the universe. And Mars is the next logical choice because Mars has pretty much everything we need to survive. We can live off the land on Mars. It has an atmosphere we can utilize. We still need space suits, not soups, space suits and habitats. But you can use the atmosphere, the CO2 atmosphere, and there's water on Mars. So you can create methane fuel, oxygen, and water. And then using that within habitats, you can grow food most likely on Mars. So that's another reason. But other reasons are the inspirational value. It can just inspire the country and the world, bring everybody together, but it'll also require innovations that would be required for sustainability on Mars, but could also be used here on Earth. So by going to Mars, we are improving life on Earth and probably creating an extraordinary number of markets here on Earth. So it's not just throwing money into space. This is truly investment here on Earth and improving life here on Earth by exploring space.
And microbes is an important point to mention for sure. What are the benefits? Is it worth the billions of dollars putting the whole program together to get humans to Mars? And is there any political benefit as well? Because I'm sure that's a big part of financing the mission.
Our whole society is completely different, improved from what it would have been otherwise. People don't understand. We live in a space-based society. You don't think about it, but we're using our phones, we're watching weather forecasts, we're doing and using GPS, any sort of communication, modern day communication is completely reliant on it. Our military is completely reliant on it. Just every day, we use space technology in innumerable ways. And that just a small microcosm of what it'll be as we're really beginning to move out now. We are truly at the beginning, and it looks like the golden age. And the benefits are just going to dwarf what came before with the Apollo program. And those were not small and insignificant. And you talk about spending billions of dollars. Yes, it's expensive, but this is where people get confused on budgetary context. NASA accounts for less than half of 1% of the federal budget. It's a tiny percentage compared to things like the military entitlement programs or most of these other big programs. This is a tiny percentage, yet it has such a big impact. Plus, it also has bipartisan support, which there are probably right now in this country. Probably you can count the number of things with bipartisan support on 2 or 3 fingers. So for something that has so much benefit and can bring the parties together, I think there's real value there.
What do we need to consider to go to Mars? What are things that we have to consider, take into account? What are the challenges of going to Mars? And once we get there, is there a time frame that we need to stay there for?
Well, there's a lot of things we need to consider. Luckily, right now, we have a lot of different launch vehicles being built and tested. Of course, the Artemis 1 mission flew late last year. SpaceX looks like it's going to at least attempt its first orbital launch of Starship next month. But there are a lot of different systems in development now. But the things we still need to figure out, for instance, we need to figure out if we can land on Mars. I mean, it's not as easy said as done. The biggest thing we've ever landed on Mars is 1 metric ton. And that's both the Perseverance and the Curiosity rovers. But we're not going to land humans like that, because if you recall with those rovers, they were lowered down with the sky crane, like basically lowered down on a cord, with a retro rocket pack. We're not going to do that, and we're not going to land humans with airbags and bounce in either, like we did with the smaller ones. So we have to figure out how to get through the atmosphere, slow down with basically minimum 20 metric tons, probably more like 40 metric tons. So that's a big one. But we also have to figure out if we can have sustainability and also create habitats. Thinking about the crew, because people talk about, oh, well, we just send people there and they'll stay there a year and a half and then come back. Well, that's a long time, say 3 years away from Earth. with a crew in a small confined space, you have to figure out a lot of things to make sure those people, not only are physically fit, but, maintain mental health along the way as well. So there's so many different systems involved in the whole, keeping, biomedical health and mental health. And then figuring out if we can create sustainability, how are we going to eat, how are we going to breathe, how are we going to drink, how are we going to maintain, once again, medicine on Mars, how are we going to do all these different things. So there are a lot of different things we have to think about before we go, but these are the sort of things I also think when we're trying to figure out how to do them on Mars, we may have those giant leaps forward in technology and innovation that because we were looking at the problem within the Mars context, this harsh environment. And all of a sudden we realize we've made a tremendous step forward that we can bring back here on Earth.
Well, for sure, it's not easy. Radiation is a problem, I believe, in terms of en route to Mars. And then once we're at Mars, being exposed to the radiation, how is radiation considered into the big picture of going to Mars?
This is an area where there's disagreement within the community. Now, there is definitely radiation, no question about that. But when Curiosity went back in 2012, it did carry radiation sensors and in transit on the surface, and those readings actually were less than they anticipated. They were basically. I forgot what the percentages were, but it would mean that crews would, if they went to and from Mars, it would account for what current standards are, the maximum amount of radiation an astronaut's allowed to be exposed to in their lifetime as an astronaut, which means a small percentage, a few percentage increase of potential cancer sometime in their life. However, if we're sending this radiation level, unless it's an extrasolar event, which is easier to shield actually with water, but it's not going to kill you instantaneously on the mission. And so most people would accept a certain, a few percentage increase of cancer sometime in their life to go there. So this isn't necessarily a deal killer. We have to figure it out, find countermeasures, but it is not one of these things. Some people make it out to be a deal killer, and we want to spend billions of dollars to try to reduce that. When is it really worth, the extra expense, particularly on the initial missions, when we're only talking about, small percentage increases of the chance of cancer sometime in the life of the astronauts. And of course, that gets smaller and smaller the older the astronauts are.
I was with an astronaut, actually, bringing him to the McCall Shepherd Discovery Center for a program. And one thing that I thought was interesting that he shared with me was that there's no shortage of astronauts that would be willing to go to Mars, realizing that it was a one-way trip. So I thought that was a fascinating aspect, viewpoint of an astronaut going to Mars. So how long does it take to get there? I know we said a little earlier about the stay, but tell us a little bit about the timing to get to Mars. And again, what about the stay on Mars?
Generally, with current chemical technology, it's generally between 6 and 9 months to get there. There are two different landing options and lots of variations in between. Basically, essentially a short stay and a long stay. Short stay, whereas you'd stay about 30 days on the surface and then you'd head right back, and it accounts for maybe a 500-day mission, or maybe a little more than that actually, but the short stay. But then the long stay, which most people prefer, but there's concerns about how long the astronauts are away on the first mission. But that would essentially be the same amount, about 6 to 8 months there, a year and a half on the surface, and similar time back. So generally, you're away from Earth about 3 years or that. So regardless, it's either way, just because of the way the planets are aligned with chemical propulsion, that's how long it takes. And of course, we can only go every 2 years based on current technology because of where, the planetary alignment, where Earth and Mars are in relation to the sun. So you have to time it. So when you're sending them out, your spacecraft meets up with Mars, can't be too far away. Maybe with, they're talking about different forms of nuclear propulsion that might be able to speed that up dramatically. And maybe that'll, be nice if we didn't have to worry about that 2-year window eventually. But even within that window, some people think we can narrow it down to like 39 days to get there. But that's technology is still not here yet.
So that's pretty interesting, for sure. And one of the things that mentioned earlier in terms of consideration is oxygen, for sure. So I understand that there is a unit, an experiment, a prototype on board Perseverance called MOXIE. And MOXIE is taking oxygen out of the carbon dioxide atmosphere and turning it into oxygen. Well, how's that going as a prototype? I understand it's about the size of a large toaster or a small microwave. And how large of a real machine do we need to make in order to create the amounts of oxygen that is going to help us to sustain life for a period of time on Mars?
I don't know the exact size, I'm just that's
Right.
a little out of my range, the engineering, how it scales up, but it'll be a lot larger to be able to sustain, 3 or 4 astronauts. But regardless, this is the first time we've actually been able to manufacture resources on Mars, to use the atmosphere to create oxygen. That was critical. That is perhaps, when it comes to precursor missions for humans, for sustainable long-term human presence on Mars, the MOXIE mission I can't think of any that's more important than that, because without being able to live off the land, use ISRU, in situ resource utilization, we are not going to be able to have sustainability on Mars or anywhere else. So the MOXIE mission was critical. We were pretty sure it would have work. It's basic chemistry utilizing CO2, but until you're there, you don't know. So it worked well. And so they proved out the concept. So hopefully there'll be follow-up ones. And when we send, the initial missions to Mars in the 2030s, even if we don't use it on the initial missions, we certainly hope NASA and commercial partners and international partners will prove out the technology in a bigger way, bring larger ISRU apparatus to be able to test out, trying to generate oxygen and water and fuel on a much larger scale.
Very cool. When do you think we'll actually find our way to actually get to Mars?
Well, right now, just on the formal policy level, NASA's current policy is that we're going to land on Mars no later than 2040. We would like to do it sooner than then. Explore Mars has been pretty much advocating no later than the mid-2030s, hoping to do it sooner. And frankly, we would like to utilize the 2033 option, because that is a unique year for planetary alignment, when you can send equipment to Mars with less energy and with more mass. And so we may not be able to land on the surface, although certain companies like SpaceX think they can, and if they can, that's great, but I'm not going to hold my breath. We'll see. But let's figure out how we can use it, even if it's an orbital mission, to, check off a lot of boxes on, because we're going to need to figure out if we can have systems that'll keep people alive in that transit period and going even in orbit. So there are a lot of systems that we need to test out, which we could do in some sort of mission in 2033. But we're hoping that we'll be able to have a landing mission by the mid-2030s, 2035, 2037 at latest. But as I said, NASA's current goal is no later than 2040, but no later than 2040 means all of the 2030s. If you think about it, it's just whether we can actually maintain and build that political momentum, and if all these systems and missions coming up can move ahead, without delay. part of this is, will the Artemis missions move ahead on schedule? Will the Artemis 2 one, which will have a crew going around the moon, go in 18 months? And then will Artemis 3 land humans back on the moon in 2025? I hope so. And so if we can keep the momentum going, and the more momentum you see, the more excitement there is, and the more pressure there'll be from elected officials. And this is the sort of thing that when you see evidence of success, it just generates more excitement and more support. But meanwhile, on the commercial end, every day there seems to be something new and exciting, new companies building launch vehicles or new capabilities that are required. So it is a very interesting time. I think the next decade will be just fascinating.
So, Chris, thank you for that. And how do we deal with the psychological and physiological particular issues? As we know, sometimes we have, often we have astronauts up on the International Space Station for 6 months at a time. And when they get back, a lot of them need some serious rehab to get back to operating in full gravity in terms of walking and just doing everyday things. So we're talking about, let's just say, a 7-month trip to Mars. When they get to Mars, there's not going to be a swimming pool, there's not going to be a rehab facility, I don't think. How's that going to work? And then obviously it's another 7 months getting back. How do we deal with the physiological effects that are just going to be present on a long trip to Mars, a stay on Mars, and a long trip back?
No, it does. That is one of the big concerns, the microgravity environment, the impact on the body, also like on the eyes as well.
Yeah.
Although some astronauts have been up for quite a while and come back and been able to walk off. And, some people react to it differently. And if you stick to the exercise regimen, it does make a big difference. So there, and this is one of these questions. And it's also something we're hoping NASA will do more of. They have plans of this to actually, rather than, I know this is not trying to be dismissive, they've gone through real physiological challenges, but rather than having a whole army of doctors, swarm around the astronauts the moment they land, maybe after some of the missions, send them directly to an analog mission and see what they are able to do, to set up base, just so we can really see what it would be like when astronauts land on Mars. How long will it take for them to acclimate without a team of doctors around them? And how quickly will they be able to start doing the basic requirements of maintaining a base on Mars, habitat on Mars, and start their whole exploration process? So we're hoping that NASA will do more of that. They have plans for things like that, and they've done a lot of different sort of analog work, but this kind of combined effort of, having astronauts stay on ISS for a while, then come back and do an analog Mars mission, I think would be very interesting.
Fascinating, absolutely fascinating. Well, Chris, thank you so much for being part of our show.
Thanks for having me on. It was fun.
Hey, I hope you enjoyed that chat with Chris Carberry, and I also want to let you know that there's a Humans to Mars conference, convention actually, May 5th to 8th. It's in Washington, D.C. at the Academy of Science building. So don't miss that if you have the opportunity to get down to Washington, D.C. Thanks again, Chris. So we're talking about March 1st and 2nd. Look at what's happening right here. It looks like two things on top of each other because they are. We're looking at Mars. Sorry, we're not. We're looking at Venus and Jupiter so close to each other, because if you've been watching in February, Jupiter was higher on its way down towards the sun, and Venus was coming up away from the sun, and now Venus and Jupiter are meeting really close, like less than the width of a full moon on March 1st and 2nd. So hopefully one of those nights will be clear, and this is like about 6:30, soon after sunset. So don't miss that conjunction of Venus and Jupiter. That'll be pretty neat. That's, again, March 1st and 2nd. All right, so we're going to jump ahead now to March 20th. And what is March 20th special about? Well, March 20th is the vernal equinox. It's the first moment of spring at 5:24 p.m. on March 20th. It's not the 21st, it's March 20th. And I thought what I'd do is show you a little bit about, well, what is that moment of the vernal equinox? Now, this is the sun right here. I've turned the atmosphere off because normally we'd have a blue sky and the only thing you would see would be the sun. But I just wanted to explain to you what makes it the vernal equinox. So the blue line, the relatively dim blue line that you see, this line here is the equator. It's like the celestial equator, and it's a projection of our equator onto the sky. This kind of orangish line that's coming here, that comes through the sun, is called the ecliptic. It's technically the path of Earth around the sun, but since we're on Earth, it looks like it's the path of the sun around Earth. And notice also, the moon is handy there. You got Mercury close to that line, and Jupiter's close to that line, and off the screen, Venus is right on that line, and the sun defines the line. So, when the path of the sun crosses the equator, the celestial equator, on its way from south to north, is when we have that moment. So at 5:24 p.m. on March 20th, the sun will cross the equator. So if you're on the equator, the right spot, the sun will be like directly overhead. So that's kind of cool. That's what causes the equinox. Now I want you to get your eggs out and balance some eggs. Send me a picture. You have my email. It's astromannh@gmail.com. Send me a picture of you balancing eggs. Maybe I can share them on the next show if you share with me pictures, because on the equinox you can balance an egg on its end. I've even had a student balance it on the narrow end of the egg. So try that home as well, and we'll talk about the aspects of doing that experiment also next month. So that'll be kind of fun. All right, so that's what causes it to be the equinox, the vernal equinox. So next slide, we're going to stay with March 20th because it's middle-ish of the month. And what I wanted to point out to you is the key entry constellation of spring, and that's Leo the Lion. The Regulus star is the heart of the lion, and maybe you can see here the sickle of what I call the sickle of Leo, or maybe you might consider it to be like the backwards question mark, where Regulus is at like the bottom of the question mark. And then you come back over here, you see the triangle represents the hind haunches and the tail of the lion. So that's Leo the lion. And next slide, with these lines, it just kind of helps a little bit you to see it. And the way it's drawn sometimes is Leo the lion looks like a coat hanger, if you will. But it's easy to find. Regulus is a bright reddish star, magnitude 1 star, and about the same as Aldebaran, which I'm going to point out to you again in a little bit. But Regulus is at the bottom of that question mark, or the bottom of the sickle of Leo, and then again this triangle off the back end is his like hindquarters and the tail. And so pretty cool. The tail has a star. Its name is Denobla. And then you're familiar with, we're starting to move away from winter constellations, Orion, the 3 belt stars, and down to Sirius, the brightest star in either hemisphere. Procyon is the little dog star, still very much in view for you to enjoy. All right, let's go ahead now to the next date, which is important, and that's March 22nd. And this is about a little bit after sunset. So you can see the sky is still lit up, and we're about 7:30 p.m. And notice down here we have the moon and Jupiter. And that's just, and it's going to be a very crescenty moon. Like here in this image, it kind of looks like it's a full type of a moon, but it's not. It's a very crescent type of moon on the 22nd and hanging out by Jupiter. So you want to get that picture. And then the next night on the 23rd, the moon is going to be moving up a little bit so that you can see it moving in on Venus. So the 23rd will also be a nice night to take some pictures. And Venus is shining at a brilliant minus 3.9 magnitude, and it's about 1 and 1.4 or so astronomical units away from us, and Jupiter is shining at about a magnitude minus 2.2 magnitude, and it is about 5.5 astronomical units away from Earth. But if you look through a telescope, you'll notice that Venus has an angular degree of about 12 seconds of arc, and Jupiter is almost 3 times that at 34 seconds of arc. So check out the February show, so if you haven't yet, to learn about what those angular measurements are all about and the angles and minutes and seconds of arc. It's all explained in the February show. So I hope that you have an opportunity to check that out if you haven't yet. So neat things going on with the planets. Next slide. We're going to finish up here with March 30th. So we're at the end of the month. We're at the end of March 30th. And here we have Venus and Uranus really close together. We call that, again, a conjunction. Uranus and Venus are hanging out. And Uranus is a binocular object. And so with binoculars, you'll be able to find it because Venus is kind of like the light source, the lighthouse pointing towards it. And then as we get our last views, this is around 8:15 at night. This is March 30th, 8:15 or so. We're going to have our last views of, getting towards our last views of Aldebaran, the Eye of the Bull. We have here Betelgeuse, the red star Betelgeuse, all of Orion. And the star Safe, up through Betelgeuse, is going to bring us to Mars, which is glowing quite brilliantly, close to a magnitude 0 at the beginning of the month, but then dimming to about a 0.9 magnitude towards the end of the month, March 30th. So Mars and Aldebaran will be very similar brightnesses. You'll notice Mars will be a little more reddish and Aldebaran a little more on the orange side. And it kind of makes a nice triangle, Aldebaran and Mars with red Betelgeuse. And Capella is yellow. Right up as you look overhead, you'll see amazing, compelling Capella, which is yellow in color. And then Rigel at the bottom right, as we look at Orion, is a blue-white star. So you got amazing colors. You got a bright blue-white, a bright red star. You have a fairly bright orange star, a bright orange star, which is the same magnitude as Betelgeuse and Rigel, and then a reddish planet. So enjoy the colors. Take some time to enjoy the colors of the planet Mars and the stars. Hey, I hope you enjoyed the show. Don't forget, April 8th, Saturday, come to the McCall Shepherd Discovery Center. Anytime during the day, we have great planetarium shows with 8K projection system. It's really amazing. And we have the special pre-anniversary for the eclipse from 1 o'clock to 4 o'clock. That's Saturday, April 8th at the McCall Shepherd Discovery Center. I plan to be there. Hope to see you there as well. I'm Dave McDonald for the Sky This Month.